This is a rigid member. And we have 3 columns, and these columns are in parallel. As you can see, this is a column, and this is a column, and this is a column. Okay, it's very important to know the end conditions. This is fixed, and this is fixed, and this is also fixed. This is the notation that we are using to indicate fixed condition. Here it is, fixed, like that. We do that. If it is a hinge, we do it that way. So this is a hinge or a pin, and this is fixed. So it's telling you that these columns are fixed at the bottom. What about at the top? How I know the column is fixed or hinge at the top? Based on the member is connected to. If they are saying this is a rigid member, that means that this is also fixed. So I need you to remember this statement. They mentioned rigid, that means fixed. That means that all these columns is like this. Fixed, fixed. And he's telling you the relationship between I1 and I2 and I3 is given here. And assume that the top girder is a rigid member. Rigid means that's fixed. So it's asking, if you have the force P acting on this structure, this column will carry shear, or let me call it P1. This column will take a shear P2, resist, and this column will carry P3. Such that P, the total force, is equal P1 plus P2 plus P3. Okay, so this, because equilibrium, by the way, don't forget the equations of equilibrium that we learned it in school, that sigma force X equals 0, sigma force, still applied as we mentioned last time, sigma force equals 0, and sigma moment equals 0. Those are the 3 equilibrium equations. They never change. It's called equilibrium equations, and I discussed this in chapter 3. If you go to problem 3-1, I mentioned this. This is called equilibrium equations. Equilibrium equations. So it's asking the shear force carried by the first column, which is this one here, is looking for P1. How much? In a proportion to this P. It is 1/10 B, 1/5, 2/3, or 1/3. So if this is the total lateral force, seismic force, so I have P1 and P2 and P3. Okay, since the top girder is rigid, and I try to explain as much as you can, all columns will be treated as fixed top and fixed bottom. Fixed, fixed. So from this table, let me make sure that the table is correct, the table number. Sometimes I rearrange the tables. So the table 5-3, that's correct. The table that we talked about before, table 5-3. If you found there's a typo in the table, I will let you know, but can you go to table 5-3? The table that has a stiffness K, the landscape table. Do you see that? Table 5-3. At the top, you will find table 5-3. Okay? So this is the stiffness K. Did you find this? For a column that's fixed, you will find that the stiffness K is equal 12 EI divided by H cubed. This is given in the table. And I'm repeating it here again. And he said that the E and the I and the H are the same. And the problem statement, most of elasticity is the same and the cross-sectional area. So we can write the equation in the general format. And this is the equation for distribution. How much P1 will be? How much P2 will be? How much P3 will be? We distribute it that way, that I call it V1, by the way. Sorry, I call it V1. Let me erase it. I call it V1. It's not a big deal, V or P or F, but to be consistent with my solution, I name this is to be V1, which is the shear force by the column number 1, and this is V2, and this is V3. Here it is, just to be consistent with the problem. I call it V1. So V1 is equal P times K1 over K1 plus K2 plus K3. This is how we distribute the lateral force. And let me show it one more time. If I didn't show it before, let me show it. So, and this is one of the 7 rules, by the way. So if you do have a building like this, or a structure, or a bridge, and I have a force P, lateral force. This is the lateral coming from the side. So we do have, this column has a stiffness K1, this column K2, and this K3. So this here, the shear, I will call it V1. The shear for this is V2. And the shear for the third column is V3. Each column is carrying its shear, such that when you sum forces in the x direction equal 0, you'll find that P is equal V1 plus V2 plus V3. Equilibrium. How can I get V1? So V1 is equal K1 over K1 plus K2 plus K3. All this multiplied by P. Or you can say that it is K1 over K total times P. Or the third scenario, K1 over K equivalent times B. Do you see that? Why? So K1 plus K2, K equivalent or K total, this is the parallel system. Do you remember the parallel system? We are adding K1 plus K2 plus K3. The same story can be repeated for V2. V2 is equal K2 over K total for P times B, sorry. V3 is equal K3 divided by K total times B. Do you see that? This is called distribution of the lateral force in proportion to the lateral stiffness. This is the stiffness, this is a stiffness, and this is stiffness. The stiffer column will carry more than flexible column. And this is one of the 7 rules, by the way. Let me show it to you. Okay. I know I stopped at rule number 4. 5, I can remember. Here it is. And this is why I skip it until I do it for you. If you can go page 163 one more time. Page 163, please. You will find that the seismic force is distributed among the resisting element in proportion to the rigidity or stiffness. Here it is. If the diaphragm is rigid. And in this case, we take the rigid member as, so in proportion to what? To their rigidities or stiffness. Here I have a rigidity or a stiffness. I have a stiffness. Did you see that? So these are the 3 equations that can be written for each one of them. Okay? And going back to the problem. So problem number 1, 5-1. Now I know this is K1 plus K2 plus K3. K is 12 EI over H cubed. But all of them, they have the same H and the same I. The same H and the same E. And the 12 is a constant. It can be cancelled out. That means that it can be expressed in terms of their moment of inertia. But I know the relationship between the moment of inertia. I substitute. Bingo. I got it. And this is what you see here. Notes. The lateral force distributed among the columns is in proportion to their stiffness. Here it is. And another note is the same thing. Relative rigidity or relative stiffness. Makes sense. Okay, problem number 5 too. Any questions so far? Please, you are very welcome to stop me if there is something unclear or something you don't understand or something you are not totally convinced or something you need to find it out where in the book. I will be glad to help. But we need to make sure that we understand that.
I have a question.
Yes, please. What's the question?
For the equations, I mean for the answer A, the same line over there, V1 equals E times K1 over K total, right? And where does the base equation come from? For example, maybe it works back like a P equals V1 times something, right?
Can you repeat the question one more time, just to make sure that you are talking about these equations?
Yes.
Okay. You are talking about from where they are coming from?
Yes.
Okay. Coming from the rule.
Okay.
Okay. Rule number 4. Rule number 5, sorry. Rule number 5 on page 163.
Okay.
Let's look to rule number 5. This is from the code, the seismic code. The seismic force is distributed among resisting elements in proportion to their rigidities or stiffness if the diaphragm is rigid. Okay, so the problem statement that we have a problem 5.1 is telling me that the superstructure, that this one here, this is like a diaphragm, this is rigid. Here it is, rigid member, rigid. It say that the slab of the bridge or the deck of the bridge is rigid, or the rigid member is for the, so this is rigid. Since this is rigid, this force P, each one will carry portion. Each column has a share. How much each share? The share will be distributed based on their stiffness. This is K1, and this is K2, and this is K3. So this force is distributed among these resisting elements in proportion to their rigidities or stiffnesses. Here I am dealing with the stiffnesses. So I said that the first column has a stiffness K1. In relation to the total, this is a K total. Here it is. So this is the proportion. And multiplied by the force B. And the same story with the other two columns, V2 and V3. Like, for example, let me remind you of something. Me and you carrying, there is a wood, member, okay, and we hang a weight here. This is W, weight. And here is Mr. Mansour, I'm carrying here, and you is carrying here. Okay. This load will be distributed among us based on the position, obviously the location, but based also if I go down a little bit, if I try to make more load on you, okay, I will make a little bit, I will go down a little bit, more load will be on your shoulder. So the load is distributed, okay, in the proportion to our strength and their position. Here, this is for a gravity load. This is a lateral load. So they said that the lateral load, P, this is a lateral load, like seismic force, lateral load, is distributed. This is a rule given in the code. If this is rigid, this force will be distributed among these resisting elements in proportion to what? To their stiffnesses. So here is a proportion of the stiffness. Column number 1, K1 over K1 plus K2, K3, because why 3? And the same story with the other two. Make sense? Okay. So you are very, but, and after that, I substitute for the stiffness. but the stiffness is 12 EI over H cubed. All of them, they have 12. All of them, they have the same E, and all of the same height. So the I will be the parameter, will affect. And since I know the ratio, who gave me this ratio in the problem? Say I1 is equal 1/3 of I2 is equal 1/6 of I3. This is given in the problem statement. So I substitute for all of these, and I ended with P over 10. So this column will carry 10th of the load. And I can determine the other loads if he asks me V2 or V3 or something like that. You are very welcome.